And we're back. Okay, so we're going to be talking today about 4.4, analyzing quadratic functions of the form y equals a, and then in brackets x minus p squared plus q. First things first, let's talk about what each of these things actually does to the parabola. So I'm going to be talking a lot about the mother function. The mother function in quadratics is simply y equals x squared. That's what all of our graphs are going to be comparing to. Now in the last class, in today's class I guess, what we did was we did 4.3 and we talked about the different effects that these different variables have on the parabola. Right now we're just going to take down some formal notes. So this is nothing new, this should be a review. So when we're talking about the effect of changing Q, what this does is it simply it moves the graph vertically. Q units. So I'm just going to take down some examples. So we're always going to compare to our mother function, which is y equals x squared. Please note all my sweet graphing skills. I have arrows on everything. I also have marked my scale. That's very important. So the mother function is just y equals x squared. At this point, I'm expecting that most of you guys, 1, 2, 3, 4, most of you guys can graph this pretty well. 3 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look at that. It's like I planned that or something. So this right here is our mother function. So this I'm going to label y equals x squared. Well, what happens if I say y equals x squared plus 3? Well, you just move everything up 3 points. So say I was wanting to say y equals x squared plus 3. Well, all I'm doing is taking all of my points and moving them up 3. 1, 2, 3. This point here is going to be here. 1, 2, 3. Ooh, there should have been a point here that I forgot to draw in. There we go. This point goes up 3. 1, 2, 3. This one goes up 3. 1, 2, 3. So I know the one in red is going to be y equals x squared plus 3. What happens if I subtracted minus 1? Well, I'm just going to do the same thing, but subtract 1 vertically. So make all the points go down. 1. Oh, and I can actually do this one too. So the green one is y equals x squared minus 1. I'll give you some time to copy this down or at least pause. The next thing is I want us to talk about the effect of changing p. So the effect of changing p. So this is y, this is the tricky bit, okay? Because it's x minus p. What actually this does, it moves the graph horizontally p units. P units! That kind of sounds funny. So I'm just going to show you a graphical example again. Okay, I'm going to draw in my mother graph. So this I'm going to label y equals x squared. What happens if I write y equals x minus 2 squared? Okay, x minus 2 squared. That means that we're going to, it feels like we're moving to the left because it's negative, but the x's are opposite. Okay, it's saying that if you take the new x and add 2, okay, so we're actually moving to the right. So I'm just going to move this point here to the right 2, to the right 2, to the right 2, to the right 2, and to the right 2. So our new graph here looks here. Now, what happens if I had, say, something like y equals x plus 5 squared? Well, that means that we're moving it to the left. I know it feels weird, right? Because it's the positive instead of the negative. But all we do is we move all of our points over 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one will be 1, 2, 3, 4, 5, like that. 1, 2, 3, 4, 5. Give you some time to copy that down. Now, there is one more letter that we haven't dealt with yet, right? We've dealt with a Q. We've dealt with a P. What about that A? Now that's our stretching and compressing factor. So the effect of changing A. This stretches or compresses vertically. So if I were to have my mother graph again, this is my mother graph. This you should be doing as fast as I am. So if you're not doing it as fast as I am, just come and talk to me and we'll get you there. So if I were to say do something like, oh, I gotta label that, y equals x squared. If I were to say do something like y equals 2x squared, what we're gonna do is we're gonna take all of our y values and multiply it by 2. So the coordinate point for here is just 0, 0. So I'm taking 0, 0. So I'm taking the y coordinate, I'm multiplying it by 2. Guess what? 2 times 0, still 0. So this doesn't move. But this point right here is 1, 1. What we want to do to get the y equals 2x squared is we want to multiply that second one, the y variable by 2. So it's not going to be at 1, 1 anymore, but it's going to be at 1, 2. Same thing here, negative 1, we multiply by 2, and we get positive 2. This one right here is going to be at 2, 4. What this is actually going to be at right now is it's going to be at 2, 8, which is off the charts, okay? But you'll notice that this thing, when we have a whole number out in front, gets skinnier. Okay? It's like it's been stretched like that. When this number is a fraction, what actually happens is it gets a little bit wider. So if I were to have y equals 1/2 x squared, I would say, okay, so this original one is 1, comma 1. Well, with the half, I'm going to say, oh, I'm going to multiply the 1 by 1/2. I'm going to get half here, half here. The 2, it's going to be at 2 and 4, so we take the y coordinate, multiply it by 0.5, which is just going to be 2. We're seeing that this thing is going to be much wider. Okay, so this one's this one. And this one is this one. Now there's one more tricky little bit of business, and that is what happens if we have a negative here. I'm just going to draw a quick example. Where's my green? Oh. If I were to go like this, what I'm doing is I'm reflecting it in the x-axis, which is this horizontal axis. I am just taking the point here, so it goes from the x-axis, I go up 1, instead I'm going to go down 1. Okay? From the x-axis to here is going to be 4, so I'm just going to flip it and go down 4 instead. We have something that looks like this, and it is congruent, so it is the exact same shape. Okay, we talked about congruency a little bit during the class today. It's congruent with this shape right here, like it hasn't stretched or compressed, but it's just flipped. The equation for this one is just going to be y equals negative x squared. Okay, so that A has stretch and compress, but it also has the flipping in the x-axis. So these are your summary notes, and what we're going to do now is I'm going to do several examples.